Inverse trigonometrical functions, exercise 2.1. Question number 1, that is, find the principal values of the following. Find the principal values of question number 1. Sine inverse minus 1 by 2. This is question number 1. Now let this is no solution. Let sine inverse minus 1 by 2 is equal to theta, so that theta is a element of minus 1 by 2, closer interval of minus 1 by 2 to pi by 2 to 5 by 2. Theta is element of closer intervals minus 5 by 2 to 5 by 2, and sin theta is equal to minus 1 by 2. Sin theta is equal to minus 1 by 2. That implies sin theta is equal to minus sine 1 by 2, that we can write it as pi by 6. 1 by 2, that is 5 by 6. That means sine 30 degrees is equal to, since sine 30 degrees is equal to 1 by 2. We know that sine minus sine theta is equal to sine minus theta. So therefore above equation becomes sin theta is equal to sine minus pi by 6. Sin theta is equal to sine minus pi by 6. So equating LHS is equal to RHS, equating LHS is equal to RHS, then theta is equal to minus pi by 6. Theta is equal to minus pi by 6. Therefore sine inverse minus 1 by 2 is equal to minus pi by 6. This is question number 1. Now question number 2. Question number 2, cos inverse root 3 by 2. Cos inverse root 3 by 2 solution. Let cos inverse root 3 by 2 is equal to theta, so that theta is a element of 0, pi. That is cos inverse principal value. Theta is an element of cos 0 and pi, or 0 is less than or equal to theta is less than or equal to pi, and cos theta is equal to root 3 by 2. Cos theta is equal to root 3 by 2. That implies cos theta is equal to cos pi by 6. Cos theta is equal to pi by 6, since cos 30 degrees, that is root 3 by 2. Therefore, theta is equal to pi by 6. Therefore, theta is equal to pi by 6, and that is cos inverse root 3 by 2 is equal to pi by 6. Now, question number 3. Question number 3. Cosec inverse into 2. Cosec inverse 2. Let cosec inverse 2 is equal to theta. We can also write cosec inverse 2 is equal to theta, and according to principal values, theta is element of closed interval minus pi by 2 of plus pi by 2 and minus 0 and cosec theta is equal to 2 and cosec theta is equal to 2 from equation 1. Now, cosec theta is equal to cosec pi by 6. That is theta is equal to pi by 6. Therefore, that is cosec inverse 2 is equal to pi by 6. Now, question number 4. Tan inverse tan inverse minus root 3. Tan inverse minus root 3. Let tan inverse minus root 3 is equal to theta, or tan theta is equal to minus root 3. Tan theta is equal to minus root t according to principal values. According to principal values, theta is element of closed interval minus pi by 2 and open interval minus pi by 2, open interval pi by 2. Now tan 60 degrees is equal to root 3. So equation 1 becomes tan theta is equal to minus tan pi by 3 minus tan pi by 3, that is equal to tan minus pi by 3, that is equal to tan minus pi by 3. Here theta is equal to minus 5 by 3. Therefore, tan inverse minus root 3 is equal to minus 5 by 3. Question number 5. Cos inverse minus 1 by 2. Let cos inverse minus 1 by 2 is equal to theta. That implies theta is equal to, cos theta is equal to minus 1 by 2. Cos theta is equal to minus 1 by 2 according to principal values. Theta is element of closed interval 0 and closed interval pi, and cos theta is equal to minus cos pi by 3. That is equal to cos pi minus pi by 3. 5 by 3 since cos pi minus theta is equal to minus cos theta. Phi minus theta is equal to minus cos theta. Now cos theta is equal to cos 3 pi minus pi by 3, that is equal to cos 2 pi by 3. That implies theta is equal to 2 pi by 3. Theta is equal to 2 pi by 3. That is cos inverse minus 1 by 2 is equal to 2 pi by 3. Question number 6. Tan inverse minus 1. Question number 6. Tan inverse minus 1. Let tan inverse minus 1 is equal to theta. That is, theta is an element of open interval minus pi by 2 and open interval pi by 2. Theta that implies minus pi by 2 is less than or equal to theta. Theta is less than or equal to pi by 2. And tan theta is equal to minus 1. That implies tan theta is equal to minus tan pi by 4. Tan theta is equal to tan minus 5 by 4. That implies theta is equal to minus 5 by 4. Therefore, tan inverse minus 1 is equal to minus 5 by 4. Tan inverse minus 1 is equal to minus 5 by 4. Now, question number 7. Sec inverse. Question number 7. Sec inverse 2 by root 3. Sec inverse 2 by root 3. Let sec inverse 2 by root 3 is equal to theta. That implies sec theta is equal to 2 by root 3. Equation 1. It's 2 by root 3, and according to principal value, according to principal value, theta is an element of closed interval 0 and pi minus pi by 2 and sec theta is equal to 2 by root 3. That implies sec theta is equal to sec pi by 6. That implies theta is equal to pi by 6. Therefore, sec inverse 2 by root 3 is equal to pi by 6. Now, question number 8. Cot inverse root 3. Let cot inverse root 3 is equal to theta. That implies cot theta is equal to root 3. Cot theta is equal to root 3 and theta is an element open interval 0 to pi open interval. That implies cot theta is equal to cot 5 by 6. That implies theta is equal to 5 by 6. Therefore cot inverse root 3 is equal to 5 by 6. Now, question number 9. Cos inverse minus 1 by root 2. Let cos inverse minus 1 by root 2 is equal to theta. Equation 1. 1 by root 2 is equal to theta. Now, that is theta is a element of closed interval 0 to pi, and cos theta is equal to minus 1 by root 2. Cos theta is equal to cos minus pi by 4. That is equal to cos 180 minus pi by 4. 180 minus 5 by 4. Since cos pi minus theta is equal to minus cos theta, pi minus theta is equal to minus cos theta, that cos theta is equal to cos 3 pi by 4. That implies theta is equal to 3 pi by 4 and cos inverse minus 1 by root 2 is equal to 3 pi by 4. Now question number 10. Question number 10. Cosec inverse minus root 2. Cosec inverse minus root 2. Let cosec inverse minus root 2 is equal to theta. That implies cosec theta is equal to minus root 2. That implies, and here according to principal value, theta is the element of pi by 2 minus pi by 2 minus 0. So this is minus cosec pi by 4. Root 2 is cosec pi by 4 45 degrees. So that is equal to cosec minus pi by 4. Cosec minus pi by 4. That implies theta is equal to minus 5 by 4. Therefore, cosec minus 1 by root 2 is equal to minus 5 by 4. Now, question number 11. Question number 11. Tan inverse 1 plus cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. That is equal to tan inverse 1 plus cos inverse minus 1 by 2. Cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. We know that cos inverse x plus sin inverse x is equal to pi by 2. Then above equation 1 becomes tan inverse 1 plus pi by 2. Tan inverse 1 plus pi by 2. So tan inverse 1 we can write as tan pi by 4 plus pi by 2. That is equal to pi by 4 plus pi by 2. Pi by 4 plus pi by 2, that is 3 pi by 4. 3 5 by 4. Now question number 12. Question number 12. Cos inverse 1 by 2 cos inverse 1 by 2 plus 2 sin inverse 1 by 2 cos inverse 1 by 2 sin inverse 1 by 2. Now cos inverse cos 5 by 3 plus 2 sin inverse sin 5 by 6 that is equal to 5 by 3 plus 2 5 by 6 that is equal to 5 by 3 plus 5 by 3 is equal to 2 5 by 3. This is question number 12. Now coming to question number 13. Question number 13. Question number 13. If sin inverse x is equal to y, then solution. Then what? The solution. As per range of sin inverse x is minus 5 by 2 therefore minus 5 by 2 is less than or equal to y is less than or equal to plus 5 by 2. Hence B is answer. B is answer. Now question number 14. Question number 14. Tan inverse root 3 minus sec inverse minus 2 tan inverse root 3 sec inverse minus that is equal to tan inverse tan 5 by 3 minus sec inverse sec 5 by 3 that is equal to 5 by 3 minus 5 by 3 sec inverse 5 by 3 this is equal to 5 by 3 minus sec inverse sec pi by 3 pi minus pi by 3, that is equal to pi by 3 is an element of minus pi by 2 and 2 pi by 3 is an element of 0 pi minus pi by 2, that is equal to pi by 3 minus 2 pi by 3. Pi by 3 minus 2 pi by 3 minus pi by 3. Here it is minus, that is equal to 5 by 3 minus 5 by 3. Answer minus 5 by 3, answer B. Please subscribe.